What's the fart count?
I'm recording.
Why are you so cold? Hi, Graham.
Hey, Graham.
Do they have no context for the fart gun comment?
No, we said it.
Do it again.
Okay. This is going to take too much effort. Welcome to Calculus AB BC. This is BC. On November 20th, we are going to talk about vectors in the plane, not about minions and their toys.
To feel what? Shoot into somebody.
Is that in the first movie?
Yeah.
Yeah.
He's like, I said dart gun, not fart gun.
So a vector has direction and magnitude. Here is the vector AB. We call A the initial point and B the terminal point. The length we call magnitude and is notated with double F. How do you notate vectors in physics?
We write a number and give a degree, and that's it.
Yeah. When we notate magnitude, we leave off the arrow.
It's like,
If we even put the arrow on in the first place.
yeah, I think electric fields are the first time I've actually put the arrow on in all physics.
What about like if the vector is okay, do you write vectors like this?
Nope.
Okay, so standard position is when our vector is at the origin. Okay, there are two different ways we are going to write vectors. Okay, vectors are equal if they have the same length and direction. Okay, but I guess I feel like we don't need to talk about that too much, right? Same length and direction. Okay. Two vectors can have the same length and be parallel, but going opposite directions. So they have to have the same direction. So standard position, our initial point is at the origin. Okay, and that's how we like to think of vectors. All right. Component form is this. We get it by taking terminal point minus initial point. So, like, if this, it's basically telling you the horizontal and vertical components. So V1 would be how far you would go over horizontally. V2 would be how far you would go up vertically.
Double blood donation.
No, we're not.
Went wrong this time. Had that happen too? Yeah, just on my hand. Well, it wasn't blood donating, it was an IV. He's like, I went in, and my dad's like, yeah, you can stick him wherever you want, if you need to practice it. So I went in right here, you missed the vein, so then he's going like this, and I was like freaking out when he started going like this. I'm like, okay, that's
You were just
great.
being practice on?
No, I was like getting an actual IV, but my dad's like, you don't have to do it in the arm like normal if you want. You can stick him in the hand.
Okay.
See.
Magnitude is the length. Use Pythagorean theorem. Okay. The hypotenuse squared is length squared plus length squared. Okay. So we're going to take the square root of horizontal component squared plus vertical component squared.
Do you want a coordinate or do you want to make it pack? One variable coordinate or two variable?
V1 is your horizontal displacement, V2 is your vertical displacement.
Ah.
Okay, so if this is our vector, are you ready?
Sure.
If that's our vector, okay, if PQ is our vector, then its component form is -2, -2. We have to take terminal minus initial. So -5 minus -3, or -2. 2 minus 4, -2. So our component form is -2, -2, which would look like this in standard form. Okay, I think that's the easiest way to visualize vectors is in standard form. Okay, how do we find the length of this vector, aka the magnitude? Okay. Two square root of 2. I feel like you are bored. Are you bored?
You guys mentioned a lot.
And now we integrate with that.
No. Nothing today is really going to be new to you. Okay? But we need to talk about vectors so we can talk about vectored valued functions.
Oh, that's not
Right? Yeah.
Which is vector value function.
Oh, is
We're learning that.
I'll teach you after Thanksgiving.
Is our
I meant
our like
Thanksgiving.
magnitude,
So I'm like,
is our direction?
Um,
you're right. You're still
No, it's
I got you. That would be neat. Why don't we have equations like that?
Yeah.
let's just talk about vectors, and then the Monday after Thanksgiving we'll talk about vector value functions. Okay? You guys are getting very excited. Okay. So if we want to add two vectors, we can do so by adding the components. Pictorially, here is U, here is V, here is U plus V. So if we take vector U, if we're going to add vector V, we would put the initial point where the terminal point is for U, and then we could connect the two.
Yeah.
Okay? So visually, that is what we are doing when we are adding two vectors. If I wanted to take U minus V, what would we do different with V?
It makes some very natural.
So V would have to be negative, which means it would go in the opposite direction, right? And yes, we would just simply subtract the components, okay? What?
Vector addition.
Kathy's excited.
Mr. Marsh.
What about Mr. Marsh?
We do a lot of vector addition in physics.
A lot.
Anything with forces,
A lot.
anything with magnetics.
That's basically what we're learning now.
Okay, scalar multiplication. If we take a... What?
It's new.
This is not new.
Yes.
You took free calculus.
Oh, it's new
Might
to
as
me
well be
now.
new for how long ago freak out.
Okay? Scalar multiplication. We're taking a vector, and then you're going to take a scalar throughout the whole vector. So if this was vector u, for u would look like what? For u. Can you handle that, Aunt Kathy?
I think so.
Okay.
was. That was his fun, right?
Definitely don't think you
Okay, negative means our vector is going to go in the opposite direction. So it's still going to have the same magnitude, it's just going to go in the opposite direction. So essentially the vectors would be parallel. So a vector and its opposite are parallel. What would a unit vector be?
A vector with units.
I like his answer.
I dislike
No,
his
okay.
answer. I've heard the term before. I seriously what's
Yeah,
it
I
mean?
know because I taught it to
A
you.
vector is one unit
And
long.
you.
Yeah, I might not.
And you.
Yeah, that would make sense.
Like
Like a unit. Search on your site.
And you.
It might be a unit vector. It's one unit.
Even if I
long.
had to, this was 2 years ago.
One unit long. Or useless polar units.
Get a hand.
Hey, I was right.
You said vector with units.
I then said a vector that is one unit long.
He did.
And
He
that
did
would be
change it.
correct.
Wow.
A vector with magnitude 1 is a unit vector.
No, that's how they notate the magnitude.
Okay. Double ups.
Okay. So an important concept for us to know is how to find a unit vector in the same direction as a vector that we have. So if that is something that we want to do, this is how we would do it. Which, I don't really like this.
There's so many bars there.
I know. I like this way. I thought I had changed that, but apparently I did not. Okay, so a unit vector in the same direction as v, we would find by taking our vector and divide it by its magnitude. Do you believe me that that would work?
No.
You don't believe me that that would work?
Anything divided by itself, including
So that is our vector. Divide it by the magnitude, right? So then our unit vector would be this, right? No?
I said yeah.
Oh,
I'm sorry.
okay. So if we wanted the magnitude of that, then we take the square root of v1 over magnitude of v squared plus v2 over magnitude of v squared, right? What is v1 squared plus v2 squared? The magnitude, right? Squared. So you have magnitude squared over magnitude squared, which is 1. Do you believe me now? Wait, what?
What's this? Okay, so in this, your U is just 1, is that what you're saying? Sorry, the fact that you have the V up there as 1, it's not understanding.
U is our unit vector.
Okay,
So V is this.
yep, okay, I get it now.
Okay.
So just divide the vector by 2.
Divide the vector by its vector. So the vector 3, 4. Quickly, what's the magnitude? Did I get through that?
Yeah.
I'm not that good at mental math, but I can see it. I understand it's Pythagorean triple. I just always have to do this in my head.
So our unit vector would be
3/5, 4/5.
okay. So now, do you remember some letters that were involved with our vectors? Maybe like an I and a J.
Wait, what?
Yes.
J?
Big.
Standard unit vectors. I is the vector 1, 0. J is the vector 0, 1. They are the standard unit vectors. And we
function aerobics.
very visual. Apparently you don't appreciate it.
Whoa, I didn't even notice that.
Okay. We can write our vectors instead of in component form, but as like the linear combination of our standard unit vectors. Okay? So I, 1, 0, that would go with which component? Horizontal. J, 0, 1 would go with the
These vectors
I know,
always
if you
make
take
me
a choice, you always want to guess the same thing.
Okay.
You switch, then you might not get it right.
How'd that work out for you yesterday?
Not so well.
No.
Turns out there were 3 choices at one time.
Yep. So the vector 7, 8 is the same thing as 7i plus 8j. Okay, it's just a different way of writing your vectors. Okay? All right. We also going to use some trigonometry.
Well, that's bad news.
This is the equivalent. So you can really tell what it is.
But now I'm like distracted so I think it's like a COS.
Why is this true?
Because it's a right 90-degree triangle, whatever they call them.
90-degree triangle.
A right 90-degree triangle. Okay?
Versus a
So,
left 90 degrees.
here is our vector v. What's its length? The magnitude, right? Well, here is our horizontal component. We can call it A. Here is our vertical component. We can call it B. And yes, we have a 90-degree right triangle.
I just like to think of that as a triangle with 2 90-degree angles. That's a square. Non-Euclidean, but
Here's our angle
We
theta.
could say that sometimes.
Euclidean.
Here's our angle theta. So, what is the cosine of theta?
A.
But Joyce said
Wait, yeah.
A over magnitude V. So A, which we have labeled as our horizontal component, is the same thing as magnitude V cosine theta. What is theta describing?
The degree of the angle.
The direction. The direction,
Yes.
right? Do I need to spell out how we get the sine theta?
Nope. So, yes.
Okay. So this is old hat, right?
Yes.
Okay. So, if you are given the magnitude and direction, you can write the separate components of your vector. Is basically what I'm trying to tell you here. Okay? Right.
Hello.
That's unfortunate. Okay. So a Boeing 727 flying due east at 500 miles per hour is in still air encounters a 70 mile per hour tailwind acting in the direction of 60 degrees north of east.
I can do this with a light.
Or vectors. The airplane holds its compass heading due east, but because of the wind, acquires a new ground speed and direction. What are they? So what is happening?
The plane is very strong winds. Free body diagram.
Okay.
What's the force?
Always with the free
The
body
plane is
diagrams.
flying 500 miles per hour due east.
I like kilometers.
Then what happens?
Wind.
There is a wind.
60 degrees north of the east.
So as he's flying, there's this wind acting on him. So 60 degrees north of east. So like this.
Yeah.
And so this is 60 degrees and it has a 70 miles per hour. How do we figure out how fast the plane's actually going? Why don't we just add the two
I
together?
thought it stayed.
It stays due east.
Due east.
Yes.
It holds its compass heading of due east, but
It
the
holds its
crosswind
compass.
is going to.
But the crosswind's going to blow it.
Yeah, so in order to actually keep
Would
going due
the
east, you'd have to
north
correct.
wind not of the north component of the wind's not affected. If that wind east.
Think like if you're walking straight and you start pushing to the right.
I understand.
Okay? So we're going to actually have to add these two together. And in order to add these two together, what do we need to know about them? They're components. So let's call the airplane vector A for airplane. What's its components? Let's call this vector W for wind. How do we find its components? Okay, magnitude times the cosine of the direction, magnitude times the sine of the direction. So this is 70 times the cosine of 60 is what?
That sounds right.
35.
Okay. 70 times the sine of 60.
60.622.
35 radical 3.
Sure.
Okay. So what are we going to do with A and W? Now I'm hungry. So we have 535, 35 radical 3. So that is our new vector. But I want to know the speed and direction.
Time to do inverse tangent.
Okay? So yes, we need to do the inverse tangent of vertical over horizontal everyone okay with y?
Yeah.
6.1?
4, 6, 4, 7, 1, 0.
4, 6.
4, 7, 1, 0.
Okay. And how do we find the speed?
Pythagorean.
It's the magnitude. The magnitude of A and W will be the speed.
138.
538 point what?
4,265.
What else do we label as a magnitude? Like what other units could be magnitudes of a vector? Force. Okay.
Electric field strength.
Yeah, not gonna go there here. But a speed we can consider as a magnitude, and a force we can consider as a magnitude. So think about those things when you are presented with. Everyone okay with y is inverse tangent?
Yeah.
I just never thought about that as an equation or done it in physics.
Okay. Well, because you have
I've always just looked at the triangle.
horizontal and vertical components.
No, I understand why. It's not how I think about it.
Sometimes it's important for us to know why, or to remember why. Okay? All right, here's where we get to some calculus. Woo.
No, I was happy where we were.
Find a unit vector parallel to the graph of f at the point 1, 1. Hold on, what do we need?
The slope.
The slope of the tangent line. And how do we find the slope of the tangent line?
Well, it's 6.
Yeah, we know it. You just have to.
Okay, so first of all, like, some people are writing this problem down, so I'm just gonna, like, stall for a couple
Okay,
seconds.
thank you.
Sometimes we get really excited in here, and I like that we get excited.
Oh.
Okay, so first of all, we need the, that derivative evaluated at 1 is 6. So that is our slope. So what would be a vector parallel?
1, 6.
Thank you. Our vector could be 1, 6. Right. Rise over run.
There are too many ways to close our parentheses. Brackets, parentheses.
Oh, but only one way for vectors. Okay. All right, but it asks for a unit vector. Okay. So first of all, this is a vector 1, 6 because our slope is 6. So rise over 1 would be 6 over 1, 6 for vertical, 1 for horizontal. Right. For run.
Yeah.
Now we need a unit vector. So we need to find what about v?
Magnitude. Root 37.
Root 30. 1 over root 37 plus 6 root 36.
I started a triangle.
So our unit vector
I like root.
It's nice and short.
Sure, root, I mean, can.
now technically you could write it like this. Why?
Because the scalar multiplication is given.
Okay. Direction, okay, this doesn't say like a specific direction, it just needs to be parallel, right? So it could be going one way or the opposite and still be parallel, right? Okay, so technically we have two vectors there. Now what if I wanted a normal vector? What does normal mean?
Perpendicular.
That one.
Okay,
Then we do something.
so what would our new vector be?
Yeah. No, it would be like negative 6, 1, right?
Negative.
Or
Negative 6, 1, or 6,
negative
negative 1. But it wouldn't matter because you're still going to do the plus or minus 1 over radical 37 because it could go in either direction, right? Okay, so your homework is this. Oh, that didn't get bigger. Okay, so this is all like the simple stuff about vectors. On Tuesday, we're going to talk about the dot product, and then the projection of vectors. I'm hoping this is a little bit familiar. No, projection of vectors, like a vector projected onto another vector.
Oh. It might be.
Okay, which will help us with work.
Why works the scale? Works the scale. No, these are going for it.
Well, we're going to find work using force times displacement, using a projection of the vector. The projection of force. If the force isn't going the same.
Do you just have to do it in parametric equations, or are we done with those now?
We are not done with parametric equations. So, like, we talked about parametric equations, then we're going to talk about vectors, and then we're going to smush them together.
Oh,
I know, right?
yeah.